Okay, so for the first question, it says to determine the values of the angle if secant equals to the ratio of -2 over square root of 3. And since I know that cosine equals to 1 over secant, because the reciprocal, that would mean that cosine would just equal to -2 over square root of 3. And therefore, cosine would equal to negative square root of 3 over 2 since it's just flipped over. So now that we know that cosine equals to negative square root of 3 over 2, we have to figure out where the cosine ratio is negative in the unit circle. And so that ratio is basically negative in quadrant 2 and quadrant 3. So now I was thinking about what I already know about this ratio, and special angles came into mind. So for special angles, we already know that this ratio has the related angle of 30 degrees. And also, since we already know that cosine is negative in quadrant 2, we can just go ahead and try to figure out what that angle is for this ratio. So I did 180 minus 30 since that's the related angle, and that gave me 150 degrees. So that's for the first angle that I found out. And then for the second angle, since cosine is negative in quad 3 as well, I did 180 plus 30 this time because it's still close to the x-axis, which is just 180, so that would give me 210 degrees. Therefore, so the values of theta, when secant theta is -2 over square root of 3, it would be 150 degrees for theta 1 and then 210 degrees for theta 2. So those would be the two angles of this ratio. Okay, moving on to question 2, which says determine the number of triangles formed given A equals 62, B equals 53, and then the angle A is 54 degrees, and also determine all the missing angles and sides on the triangle formed. So that is what we're going to do. And so the first thing that I did was that I basically just kind of thought out how the triangle would look if it had these measurements. So I put the angle, which was 54, and then I had 53 as B for that side length, and then A as 62. So I knew that A was going to be bigger or longer than B, so I tried to make it longer than that other side length. And so I already could tell that this was a full triangle and it wasn't cut off or anything. And this is where I figured out by looking at the triangle that it could also be two triangles, since A is bigger than B and B is bigger than the height, or vice versa, where the height is lesser than B and B is lesser than A, which is all the same thing. So that's where I figured out that it could be two triangles, and I could figure out all the side lengths and the angles for the whole thing, as well as the two triangles that are inside. Okay, so the first thing that I wanted to find out was the angle for B. So I just did the sine law and I did sine B over 53 because that's the side length, and then sine 54 over 62. And then I did 62 sine B, which would equal to 53 sine 54. And after that, I just switched over, I flipped over the 62 onto the right side, so it would be in the denominator, so that I can isolate sine B, and I solved 53 sine 54 divided by 62, which was 0.691, and then I isolated B, and then I did sine inverse, so I could find the actual angle, and I put that into my calculator, and that gave me B equals to 43.70, and so I just rounded it and made it 44 since it's 7. So now it would be 44 degrees for angle B. And then to find the remaining angle left, I just did 180 minus 54 minus 44, which gave me 82. So that gave me the missing angle on the top for angle C. I didn't put the letters yet, but that was angle C. 82 degrees is for angle C. And so I figured out all the angles for the whole triangle. And now I want to figure out the missing side length that I have, since I already have the two side lengths on the left side and the right side. I want to figure out the bottom side length. So I just use the cosine law to figure out that. So since I was trying to find side length C, I just plugged that into the equation. I did a to the power of 2 plus b to the power of 2 minus 2ab times cosine C would equal to c squared. And that was to find the side length. And so this is when I plugged in all the numbers to their designated areas. So for A and B, I just put 62 squared and 53 squared minus 62 and 53 and times those two together, and then cos of 82, since that is the angle of C. So then I used BEDMAS to figure out all the numbers entirely, and that whole equation gave me, so C squared equal to 5,738.3543. And so then I just square rooted both of them so I could get the single term of just C, and that equal to 75.7. But then I rounded that up, since it was 0.7, I just put 76. So that gave me the side length of C. And now, since we already have all the angles and sides of the whole triangle, I want to find out the angles and sides of the two triangles inside of that. So that's what we're going to do next. And I wanted to start off with the isosceles triangle, since it looked the easiest, since the two sides are already the same and they're congruent. So since I know that this is an isosceles triangle and the two sides are congruent and they're equal, I already knew that that angle was 54, and I knew that it was a right angle, which was the 90. So I just did 90 minus 54, which gave me 36 for the top angle of C. And since the triangles are kind of split in half, I just plus those two because I already knew they were the same size and same length. So I did 36 plus 36, and that gave me 72. So 72 was the whole angle for that part of the triangle. So for angle C, that was that angle for 72. And just to verify my work, I plussed all of them together to see if they would equal to 180, and they did. So that told me that I got all the right angles for that isosceles triangle. So my next step is to basically find that side length, well, the bottom length of that isosceles triangle. So I'm going to use the two sides that I already have, as well as the angles that I have, to find the side length. So I decided to use cosine law to determine the side length, since I already have angle C. So I decided just to take advantage of that and make it easy to just find the side length across from it, or opposite from it, as I should say. And so C squared equal to 3,881.9425, and then I just square rooted those to get C by itself. And then so C equals to 62.3, but then I just rounded it and just said 62. So I have the side length for the bottom of the isosceles triangle. Okay, so after this, I realized that I was going to have the same exact measurements as I was for the whole entire triangle, which when I found the angle for the whole entire triangle, it would just equal to 44, and then the C angle was 82. So what I did, even though I already knew it was going to get the same thing, so that's why I put for angle A, it's 54 degrees, since it was already 54 on the whole entire triangle. And then I would use sine law to determine the angle up on top, but it would just give me the same angle because it's literally the same exact measurements that I'm using, but just for the obtuse triangle. So I still showed my work to show how I got the answer of 82 for the C angle of the obtuse triangle, because I still wanted it to be demonstrated of how I showed my work of how I got that answer, but this is just me doing the whole entire calculations of using sine law to determine what sine A would be which I already have, it's 54. But then after, I'm going to determine what angle C is by minusing 180 with 54 and 44. And this is where I realized that the length opposite of C would be 76 again, because I'm still using the same exact numbers to determine all the angles and sides. So I said yes, it should be the exact same thing since I'm using the same numbers. So now I know that this angle would be 82 and the side opposite of C would be 76. So now I have finally finished determining all the angles and all the side lengths of the whole entire triangle as a whole, as well as the two triangles inside. Now moving on to question 3, which says use the cosine law to determine the indicated quantities. And so I have my two side lengths that are already given, and now I have to determine x centimeters, which is the opposite side of A. So since we are trying to find the A side length, I'm going to put A squared, which equals to B squared plus C squared minus 2BC, and then cos of A. So now I just put all the numbers into the formula to formulate the whole entire equation. So after I put those numbers into my calculator, I put A squared equals to 1557.1973. And so now I'm going to square root that number as well as A squared to give me just A by itself. And that would equal to 39.461. And now for B, I have to use cosine law to figure out the angle this time. And this time it's a little bit different because I have all sides and I have no angle given. So it's going to be side, side, side. But I'm going to still use the same exact formula that I used last time, with A being what it equals to. So A squared equals B squared plus C squared minus BC, and then cos of A. So since I already have A squared given, I just put 18.4 because that's what A is, and then 16.7 squared plus 15.2 squared, and then minus 2, 16.7, 15.2, and then times cos of A. But since I don't know what cos of A is, I'm going to have to figure that out. So now I'm just solving what I already have and just basically find the answer of all the squared numbers that I have. So it gives me all of these numbers. So now I'm going to have to take 338.56 minus 278.89. And then, so I'm just basically going to minus all these numbers, minus 231.04. And then I'm going to make it equal to negative 507.68 to 68. And then cos of A. So now that we're doing the left side of the equation, all of these equal to negative 171.41. And then I'm going to put it over negative 507.68 just to get it like the right number. So then that's going to equal to, obviously, negative 507.68 cos of A. Make sure you have the cos of A there. And then that's going to go over the same number, but without the cos of A. So those two numbers on the left side give me 0.33763, and so that would equal to cos of A. And now we would have to do the inverse of cos. So cos inverse is 0.33763, which would equal to cos of A, which is now 70.26 when you put it in your calculator. which when you round it, it would just be 70 degrees. So that is the angle of A. Angle A equals to 70 degrees. Okay, so moving on to the last and final question of the screencast. It's tan x plus cotangent y over tan x times cotangent y. And then that would equal to tan y plus cotangent x. So the first thing that I tried to do was basically isolate and like basically split them in half. So I did tan x over tan x times cotangent y, and then I plus that with cotangent y over tan x times cotangent y because I wanted to basically already separate them to be in the right terms, that when they end up in the end, they'll be in the right sections, if that makes any sense. And so since I already have like terms, I'm just going to cross them out. And so what's left is just cotangent y and tan x in the denominator. So I'm going to put 1 over cotangent y plus 1 over cotangent x. So this is where I figured out, okay, now I can finally convert. And so I did cotangent, which is already equal to cosine y over sine y. And then I also converted tangent, well, tan x will be sine x over cosine x. So since cotangent and tangent are equal to cosine over sine and then sine over cosine, I already know it's like flipped over, so it's like the reciprocal of that term. So I would just flip them so it would equal to the proper term in the end. So this is where I wrote a little bit of annotations just to basically justify what I'm doing, so it would make more sense to me while I'm doing my steps as well. So that's why, because the first thing I did was just cross out all the like terms, and then I put what the denominators was, just kept what was left and put the 1 over it, signifying that it's a fraction still. And then I just flipped them because of the reciprocal. And so when I flip them, it would equal to sine y over cosine y plus cosine x over sine x. And that would completely equal to tan y plus cotangent y, because sine y over cosine y is literally equal to tangent, which is crazy to me. And then I plus that with cos x over sine x, which is cotangent x. And so I finally solved the whole entire thing, which makes them equal. And now I know that they're both equal to tan y plus cotangent x. And I also found the restrictions of these identities. And since tangent was in the denominator, 1 over tangent x, I put x and y cannot equal to 0, 90, 207, 180, or 360.